Good morning, Facebook and YouTube, or wherever else you're watching this. Today, and probably for the next day or two, I'm going to go through the complete process of gold refining from start to finish. And we're going to do it mostly on scrap jewelry. So, let us begin. So, for those of you who follow me, you're probably interested in refining, or you have some knowledge already. If you've seen my videos, then you kind of know how I film. It's not the greatest, but I'm doing what I can do. I'm not a videographer, so bear with me if the camera shakes a little. I don't have a tripod or anything. Okay, so for gold refining, we have to use variety of acids. This is a lot different than silver, where you have to cement out silver from copper. With gold refining, you're mostly using just acids to dissolve the metals. And the trick with gold, because gold cannot be dissolved just by nitric acid, much like silver can and copper can, gold needs a combination of hydrochloric acid and nitric acid in order to dissolve. But since we have karat gold, which is 10 karat, we've got, 18 karat, 14 karat. I've got a couple little gold pieces here that we're testing at 23 karat that I want to just double refine just to get it back to 24 karat. Since we're using karat gold, it's a little different than just throwing it in the hydrochloric and nitric acid. First, what we have to do, we take each type of karat gold and we will weigh it. And that's where we're going to start. So this is my 10 karat. I got a couple little bits here. We're going to weigh it out and record the numbers so we can do a couple calculations. So what do we got here? We have, I think that piece is food. 10 karat gold, we've got 23.56. I don't know if you can see that. Anyways, it's 23.56. There are some calculations involved for doing gold, and I'll run you through them after we weigh this all. But we're just going to go through weighing each little bit first. We're going to do 14 karat now. And with this stuff, I went through it all. I key tested it. And with this gold, like you can see, they're usually stamped. That one's stamped 10 karat. Can't really get a good focus on it. But if it's real gold, it's most likely stamped with 10 karat, 14 karat, or whatever it is. But I key test it just to be sure, because I have seen fake gold where it's stamped a number, but it turns out it's not even real. So better safe than sorry. 15.97 grams of 14 karat. But I was going to show you this. This one I have in my 18 karat bag. But it is stamped 14 karat, but it key tested it just around 18 karat. So I was going to add this to the 18 karat batch, but I think what I'll do, add it to the 14. It's better to have a little too much copper to quart it with, which I will show you what all that is about shortly. So we got 21.57 grams of 14 karat. And once it's weighed, we can kind of just throw it in the pile here. It doesn't have to be separated after this. Got a couple little pieces of shot here. Like I said, this was my very first refine. I rushed it, and these are hitting at about 23. I didn't want to sell them because I don't want to sell anything that isn't totally pure gold. These are from quite a while ago, so just a measly 1.79. We'll round it up to 1.8 grams of 23 carat. Okay, and we'll just throw that to the side here. Okay, now the fun begins. Guess I should have got a calculator here. All right, so what we're gonna do, we're gonna start with a couple calculations. So for 10 grams, we have 23.56 grams of 10 carat. To get how much actual gold is in that 10 carat, we need to times it by this number, which is 417. Sorry about that. Apparently I cannot record and use my calculator at the same time on my phone. So what I did, I just did the calculations ahead of time, and I'll record them now and I'll just show you what I did. But first of all, I wanted to tell you about encording. Some of you may have heard it before. Some of you may not know what it is. When you get carat gold such as this, the gold forms around any other base metals. And since nitric acid cannot dissolve gold on its own, all the other base metals are protected by the gold that is in these carat metal, or in the carat scrap. So what we have to do is we have to add another base metal to bring this down to 6 carat. This whole batch has to be brought down to 6 carats of gold. Only then can the nitric acid start removing all the extra base metals. It can penetrate through 6 carats of gold. It will not dissolve it, but it can penetrate through it, and it will remove most of all of the other base metals, leaving us around 98% pure gold. And that is the first step of what we have to do, is to get this down to 6 carats. And you can enquart it with either copper or silver. It doesn't matter which one you do. I prefer to do copper, just mainly because of the amount of gold I do. It isn't really worth spending the time doing cementing out the silver and stuff for only an ounce or two of silver. So I usually just do it with copper, and if it goes to waste, no, you're not out much. You're only out an ounce or two of copper. So that's what I do. If you're doing big projects, sometimes you can find it easier to do the silver because you're kind of refining the silver as you go. But to each his own. So I'm going to show you the calculations here. We've got 10 grams of, this is what I weighed it out to be, 23.56 grams of carat gold at 10 grams, or at 10K. To get how much, and that's the same for the 14 carat and the 23 carat, the little bits. To find out how much actual gold is in that, you times it by these numbers. So at 10 carat gold, it's 41.7% pure gold. So you times that number by 0.417 and you'll get 9.82 grams of pure 24 karat gold in that amount of 10 carat. So what I did that for each one, 10 carat, 14, and I had a little bit of 23 carat. It's the same thing if you have 18 karat, 20 carat, whatever. You have to figure out how much actual gold you're going to get because you need that number to know how much copper or silver to enquart it with. So I've got 9.82, 12.57, 1.72 grams, 24 carat. It equals out to be 24.11 grams of pure 24 karat gold is what I have in this amount of gold that I've got, just in this scrap gold. Not bad for that little bit. That's kind of what we're going to expect. Obviously, there'll be a little bit of loss in there, but we're hoping it's going to be pretty minimal. But it all depends on how well you refine. So at the end of this, we'll see how close to that number we're going to be. Next, now that we know we have 24 grams of 24 karat gold, now we have to figure out how much copper we're going to need to mix in with this carat gold to get all of this down to 6 carats. So our 10 carats, we have 23.56 grams, which we've calculated up here, and 21.57 grams of 14 carat. And I'll show you why I scratched out this 23. So for the 10 carat, you want to times it by this number, and for the 14 carat, times it by this number. It's just a formula that they use. What I do, there's a website you can go on, Golden Quarting. Can't remember the name of it, but you just type in a number and it'll do these calculations for you, so you don't have to memorize this. But in the end, this is the amount of copper we're going to need for each one. For the 10 carat, we've got this. For the 14 carat, we got this. For the total amount of copper we're going to need, 44.37 grams of copper, we're going to need to quart this down to 6 carat. I'll tell you why I scratched out the 23 carat. Because 23 carat is almost pure. I'm not going to throw this in the nitric acid, because it would take a lot of copper just to bring that down to 6 carat for nothing, when we will just dissolve this later in the final step using Aqua Regia, which we'll get to when we get there. But it will dissolve this because this is pretty much pure gold. I don't really think we need to inquart that. It will just dissolve out at the end, and you'll see when we do it. This is more for like scrap gold. I'd say 22 carat and under. Even 22 carat, I probably wouldn't even inquart this. But anything under, you want to get it down to 6 carats. So we're going to use that number of copper. So we're going to measure this out. We want around, we can bump that up to about 45 grams of copper, just because that one piece of gold was testing at 18, even though it was marked as 14. I don't mind putting a little bit extra copper in there. You want to get it as close to 6 carats as you can. If your numbers are way off, it can be a real pain in the butt. That's close. Let's get rid of this little bit. What are we at? 45 to go. This is just copper shot that I made. I just get copper pipe or anything that's pure copper. I'll do one more little piece to get it around 45. I think that would be... yeah, I know this isn't too thrilling, but it's part of the process. Get little bits out, try to get it as close to 45 as we can. Let's take this one out. What's that? 45 point that. Okay. I think that's good. 45.15 grams of copper. There we go. So what we're going to do, I'm going to throw that in the pile here. The plan is we're going to take all this metal, not this little bit. We'll throw that bit at the end because it's already in little bits. It's thin. We'll dissolve that later. We're going to take all this with the copper, melt it down into little shot, and then we're going to throw that in to nitric acid to start. The nitric acid will be able to penetrate through this gold because it'll be quartered down to 6 carat. So it'll be able to get through the outer layer of gold into all the other base metals and dissolve it all as we go. Now we have to figure out how much nitric acid we're going to want to do. There's a lot of calculations in doing gold because there's a lot of different acids to use. The first thing we start with is nitric acid. We have 44.37 grams of copper. To figure out how much nitric acid is, or how much nitric acid to use, times it by whatever that number is, times 2.5. That'll tell you how many milliliters of nitric acid you're going to want. In this case, it's 111. I may bump that up to 112 just because we kind of made that 45, not 44.37. And whatever number that is, you want to use the exact same amount of distilled water. You don't want to do just nitric acid. You want to do a 50-50 split. So we'll do 112 milliliters of nitric, 112 milliliters of distilled water, all at the same time. We'll throw this in when it's all melted down into a little shot. And that should be That should be able to get most of the base metals out, so we can hit around 98-99% pure gold just by doing that. The second part of it, and this will be the second last real step, it's called Aqua Regia. This is where you want to dissolve all the remaining gold. And this is when you use the hydrochloric acid and the nitric acid mix, and that'll take out all the gold. It'll dissolve everything into a solution, and then from there we'll precipitate the gold out of the solution, and that'll give us the pure gold powder. To figure out the Aqua Regia numbers, the same idea. It's 3.8 milliliters of hydrochloric acid per gram and 0.95 milliliters of nitric acid mixed with that per gram. So in our case, we've got 24.11 grams of 24 karat gold, which we've got up here. Times it by that number on each one gives us 92 milliliters of hydrochloric, 23 milliliters of nitric. That will be enough to melt all this down to be dissolved. I'll show you the real proper way to do this. You don't want to mix these all together at once for Aqua Regia. You want to put in the nitric acid first. So we'll put 92 milliliters in. And then you want to do little bits of nitric acid every minute or two. You don't want to do it all at once or you're going to get a big reaction, probably boil over. You want to do a couple milliliters at a time, which I will show you as we do. And if I'm feeling a little lucky, dangerous, I'll put a little extra in there so you can see what happens when you put too much in at once. We'll see though. We don't want to melt ourselves. But you know, it's educational, so we'll see. So that's kind of where we're at. Our first step is, now that we've calculated all this, we're going to go put all this in a crucible, melt it all in together, stir it up, make sure it's mixed in, pour it into shot, and then we're going to get our nitric acid ready to go and start dissolving all these metals out of the gold. That will be well, I guess it's really step 2. This is step 1, that'll be step 2. All right, let's do it. This is my little shot setup. I got my crucible here that I've melted copper in before. I figure I'll just reuse that. It's seen in better days before. I got something stuck in there, so I had to crack it at one point, but it's gonna work for melting the gold and the copper together. Not sure how I'm gonna film this, so I may just, I'm not sure if I'm just gonna skip this part and show you just when I get the shot done. Pretty much I've got this Bernzomatic blowtorch. I've got 2 of them. I'm just gonna warm it up. I'm gonna put all the gold and copper in there, melt it in, mix it up, and just drop it in my little bowl down there, and that will collect all the shot. So what I normally do first is just kind of give it a little coating here to burn off any grease or anything until it gets red. It's easier to do with 2 hands, but I've already kind of done it. At this point, I'm just going to melt it all into one big ball of liquid and then just pour it into the bucket and make little thin balls of shot. And that's what we're going to use to melt, or to dissolve in our acid in the next step. Pretty cool looking, eh? It doesn't take too long. The gold is pretty thin, so it'll melt a lot quicker. The copper may take a couple more minutes. But just want to liquefy this and then just dump it into the bucket of cold water. I'm going to put this down because I'm going to use both torches just to speed up the process here. But that's all we're doing here. So that is it. We melted it down, made it into 6 karat gold, which is encorded with copper. And looks just like this. Nothing fancy. And from this, next step, we're going to use our nitric acid and distilled water calculation that we just did in our previous bit of the video. And we're going to begin nitric acid treatment. And that will get rid of all the base metals that it can get into. Hopefully that'll leave us around 98-99% pure gold. It should make this look brown as opposed to coppery and goldy look. So that's kind of the idea. So we're gonna go get the nitric acid and set up our little table outside, and that's gonna be our next step. Okay, as always, I got my little setup here outside. I put in our copper and gold shot. And we got our little calculations here of how much nitric acid we want. And we have it listed at 111, which I think we were going to bump up a little bit. The thing with copper versus silver is copper seems to take about 3 times more nitric acid than silver does. So our 111 milliliters may end up being a bit more, but we're going to start with 111, and if we need a bit more, we'll just add it as we go. And you can usually tell when you need to add more because you get red fumes, and the more red fumes you get, that means that the nitric acid is still being used. So we're gonna add, I might bump distilled water to about 150. So I'm just putting it in here right now. Checking as I go. That's about 150 there. Nitric acid now. We're gonna turn up the heat. You always want to put the distilled water in first, not the nitric. Distilled water seems to limit the reaction that the nitric acid does. It can contain it a bit. Oh, it's starting to snow a little bit out here. So I just turned the heat on a little bit. We're going to add the nitric in now, which I'm going to do with my body here. Start to see some fumes coming. There's the green tinge. What are we at here? A little bit more. Can already start seeing it fizz. That should be about as much as we need right now. And we're just going to let that boil up. And I like to put a little lid on it like this. That way it contains the fumes a bit. You can see them building already, the orange, reddish fumes. That is stuff you don't want to breathe in, so that's why we do it outside and downwind if we can. I usually have my little fan going here, which I'm probably going to set up in a moment, just to blow any fumes that may come our way out of our face, because this isn't stuff you want to breathe in. So you're always better to be safe. You can see the wind's blowing a bit this way, so what I'm going to do, yeah, there we go. Now it's going down. I'm going to set up my fan and just blow any fumes that the wind may blow this way out of the way. Well, that's quite the reaction, eh? We're just going to let that do its thing for a bit, and I'll check back in. Okay, we're about 10 minutes in, and the fumes are looking angry, which is good. That means all the nitric acid is eating away at the copper that we quartered our gold with. It'll be getting into the gold and hopefully getting not just the copper, but any other base metals that were present. But so far it's looking good. This is what you want. The darker the fumes means the more base metals are getting hit by the nitric acid. Once these fumes go away, that means either A, the nitric acid is all used up, or neighbor just drove by there. Either all the nitric acid is being used up or there are no more base metals to be used. So we're going to give this a little bit longer. It's going to take time. Copper dissolves a little slower than silver or other metals. So this is only about 10 minutes in. We got a ways to go. So we are about 40 minutes in now. The reaction is dying down, but it's still going strong. Looks pretty cool. Still got a ways to go, but all the base metals are getting dissolved. That solution is nice and blue now, which you know is copper, is always a blue solution. So a lot of the copper is getting dissolved right now. When this reaction dies, I may put a little bit more nitric in and just see if we continue to get a reaction. Just because copper does take more nitric acid than silver, which may bump our calculations up a little higher, but we'll find out when we get there. Right now we're just going to let this keep going until none of that orange fumes continue. But we'll see, probably another 20 minutes or so. I'll check back and we'll see where it's at. Okay, as you can see, the reaction has almost completely died down now. I'm going to add just a little bit more nitric acid, and this is just going to see if there are any more base metals in there, or if the nitric acid is used up, or if all the base metals are gone. Not adding a lot, just a little bit, and we're gonna wait and see if we have any red fumes coming out here. That will be, oh yeah, see, we're getting some red fumes. So what I'm thinking is all the nitric acid has been used up. Since we're using copper, we kind of expected that we're going to need more nitric than we originally calculated, but there are some fumes coming. So you want to do a 50-50 split between distilled water and nitric acid. So what I think I'm going to do is go ahead and add some distilled water. Not too much, but enough to get everything dissolved into. As you can see, there's the material down there. I'm going to go ahead and add a bit more nitric now. Let's see. That should be good there, I think. And if we need more, we can always add more. It's better to do little bits at a time than a whole bunch at once, because then you have a lot more waste if you don't need it. So we're going to let this boil, and we'll wait a few more minutes and see what kind of reaction we get going here. About 10 minutes into round 2 of nitric acid. As you can see, we've got a good reaction going still. We're going to let this one die down just like the first time, and when this dies down, we'll add probably another 20 to 30, maybe 40 milliliters of nitric, just little bits at a time, and just gauge the reaction. As long as we get a reaction, we'll just keep on adding it. Once we get the reaction to stop, then we're done this process and we move on to the next. But as of right now, still looks like there's quite a bit of reaction going, so I'm thinking we'll probably have to do at least one more round of this. But we'll see. We'll do it together and we'll get through it. Okay, we are, I think, done part 2 of adding nitric acid treatments. You can see the reaction has died down significantly. So we're gonna do a third one. I'm just gonna add just a little bit and see if there's a reaction. If there's a reaction, then, like I said, you don't want to add a lot. You just want to add little bits at a time and let that warm up a bit and see if there's a reaction. If there's no reaction, then I think we are done this part, and we move on to the next step. So there's a little bit of a reaction still going, as you can see. Just going to swish it around a little bit, stir it up. Sometimes the nitric can just sit at the top and not hit the metals until it heats up and gets stirred around a bit. I also like to put the little lip here on it so it goes downwind. So when that heats up a little bit more, you'll see the reaction happening, which you can already start to see it. So there are still base metals in there. So this is our third reaction and use of nitric acid treatments. We'll see how this one goes and continue on. So we're a few minutes into the third round of nitric acid treatments. As you can see, there is a good reaction. There's still plenty of fumes, which means that there's still plenty of base metals still getting used up by the nitric acid here. So as I said, copper can throw off your calculations a little bit since it uses more nitric acid than silver would if you were to quart it with silver. That's just something to be aware of. If you ever do this and you don't want to use a lot of nitric acid, then silver can be a good option. But for me, we're not doing a ton of gold, so it's really not that much more nitric acid. As you can see, we're only at 450 milliliters in total, not even 400, and half of that is distilled water, so we're probably running about 200 mils right now of nitric acid. But as the metals get dissolved, the nitric acid gets used up. So when you do have this as waste, it's not nitric acid you're disposing of. It is copper nitrate, I believe, because, well, it could be copper nitrate, it could be some silver nitrate, because it's all dissolved into the base metals and used up. But like I said, copper can use just over 3 times as much nitric acid as silver. So I assume we're going to have to do 1 or 2 more of these little nitric acid treatments. I just do a little bit at a time because I don't want to overuse it. So if we have to use 3, 4, 5 times doing this, that's fine. It's a game of patience, which isn't always easy to do in something like this. You want to just get it done, you want to see the end result, but you have to be patient. Just do little bits at a time. That way you have less waste and your numbers can be a little more accurate in the end. So we're just going to let this boil through. When those fumes go away, then we're just going to do it again. And we'll do a 4th treatment after this. Okay, so our reaction is starting to go down a bit. Once I let this air out here, you'll see it doesn't form as quickly. So I think we're going to start round 4 of nitric acid treatments. One thing I wanted to show you, or at least tell you, if you guys don't have a large beaker and the liquid starts getting really high, if you're not planning to recover, even if you are planning to recover this, you can pour off that solution into a separate beaker or glass container, save it for later, or just get it ready to dispose of for later. This solution isn't needed unless you're planning to recover it, but you do need to have distilled water and nitric acid in there. But if it gets too high, you can pour off some, give yourself some space so you don't get some overflowing burning nitric acid or anything. And every time you add nitric, you want to make sure that you have enough distilled water in there as well, because you need something for these metals to dissolve into. So if you don't have enough liquid in there, you won't get a good dissolve of the metals. I don't even know if they will dissolve if they don't have enough solution. That's a good question, actually. But anytime you add a little bit of nitrate, add a little bit of distilled water as well. This is our 4th nitric acid treatment, I believe we're on. I'm gonna have to let this warm up a bit, and then you'll hopefully won't have too much more to go. But let's let this warm up and we'll see what kind of reaction we get. Okay, our reaction has died down again, and so we're gonna go do one more treatment of nitric. It should be about the end of it, I think, after this one. You can see, well, maybe you can't see, but when I get rid of the liquid after this treatment, you're going to see all the remaining gold is going to be a brown. Just a bit more nitric in here. Like I said, we're just doing little bits at a time. The sun's finally coming out, which is a perk to the day. Makes being out here a little more fun. It's not too cold, the sun's coming out, and we're refining gold. What more do you need? So, I'm gonna let this, actually what we should do is switch this around a little bit, stir it up, get it mixed up a bit. We're just gonna let that cook for a bit and see what kind of reaction we get. And I have a feeling this will be our last nitric treatment, and we can move on to the next step. Okay everyone, as you can see, our reaction is complete. There are no more fumes coming. I added a very little bit of nitric just to see, and there's nothing happening. So I think all of our base metals are going to get as dissolved as possible. So what I'm going to do is turn the heat right off, and we're going to let this just cool down naturally. I think I'll just put this on the ground and just let it cool down a bit, because that is still boiling and there could be a little bit of nitric in there. Can't do much with that without dissolving whatever we put it into, which we're gonna eventually put that into a waste bucket, because we're not gonna recover that copper most likely. So we're just gonna let this cool down, and then we're gonna move on and take out the liquid, rinse it off, and then we're gonna start the process of dissolving the gold with hydrochloric acid and nitric acid. That's the next step, but first this has to cool down. So probably in about 20 minutes we'll come back and we will start the next step. Okay everyone, I've taken it off the heat as I showed you, and I just rinsed out all the water. There's still a little bit of blue in there. I might just give it another little rinse, and I put all the waste just in my regular waste bucket over here, which I will dispose of in coming days. But this is what it looks like. It's exactly what you want it to look like. Looks like just brown chunks. If it's crumbly, then you know you've imported too much or your numbers were way off. But it looks pretty solid. A couple little pieces down there, but mostly it's pretty solid. It's exactly what we want. I'm just going to give this another little rinse, and then we're going to start with the hydrochloric acid. Okay, so I've just rinsed off any remaining nitric acids and distilled water. It's important to note that you don't want any distilled water remaining in the beaker, and you do not want to mix distilled water and hydrochloric acid at all. If there's a couple drops, it's okay, but we are not adding any distilled water in this part of the process. It reacts violently with hydrochloric acid. So we're going to add some hydrochloric acid right now. quite a funky color. You get a nice yellowy green tinge to it. This alone will not dissolve gold, but I'm going to turn the heat up a little bit. It's very important to note that when you add your nitric acid, which I'm going to do right now, we only add little bits at a time. Do not add it all at once, or you will get a reaction you do not want. So just going to add a tiny bit right now. And the heat's not on, so, well, the heat is on, but it's not hot yet. So that's all I'm going to add right now. I turn the heat on, and once this heats up, you're going to see some serious stuff going down. Just joking, it's not that bad. We're going to put our lid on. Right there's about 150 ml combined right now. When this gets hot, that's when you want to add little bits of nitric acid at a time. I will show you as we go. It's going to take a few minutes to warm up, but this is going to dissolve all the gold and any remaining base metals. Right now, this is sitting at about 98-99% pure gold, just as it is, but we want to get it dissolved, and then we'll re-precipitate it out, which I will show you. Hey! So for this, we need hydrochloric acid and nitric acid, as I've showed you. Other materials you'll need are sulfuric acid. You only need a pinch of that, maybe a tablespoon, but we add that in a little bit. And you'll also need sodium metabisulfate. And that is what we're going to use when all the gold is dissolved into this liquid. We use sodium metabisulfate to precipitate the gold out back into a solid form, and it will only precipitate gold. It won't precipitate any other metals, and that's what gives us the pure gold. So kind of like how with silver you can cement it out on copper, with gold you precipitate it back out into a solid form with chemical, or I guess it's a chemical, yeah, sodium metabisulfate. So here comes the boiling. It's starting up now. You're going to get some fumes going here. And it's the same process we were doing with the first bit with the nitric acid treatment. We're just going to add little bits at a time. You don't want to add too much. We definitely don't want to add too much nitric acid, because when we do add the sodium metabisulfate later, any excess nitric acid is going to eat up that sodium metabisulfate. Sorry, these names are crazy sometimes. And then it won't precipitate out until all that nitric acid is used up. But if you have a little bit left over, you know, it can't be normal. You just keep adding the sodium metabisulfate until you start getting gold powder. But we'll get to that next. That's the next step after this. Right now, we just want to dissolve this gold, and that's where we're going to start. So there's the fumes coming. It's eating away at the gold, and it will dissolve into this liquid just as it's doing. Just to make a note, we started this around, I can't remember if it was 8:30 or 9 in the morning, and it is now 12:30 or so. So we've been going for three and a half hours, and we're at this phase now. After this phase, it doesn't take too much longer. We probably got a couple more hours to go till we finish. So it is a bit of a process, but dissolving takes time. This is where we're at now. I will check back in as the reaction dies down, and we'll add some more in. Once this reaction dies down, we add just a little bit more nitric, and we're going to get a big reaction every time we do. and I will show that on camera so you can see why you don't add it all at once. And I almost forgot to add in this little bit of gold shot that we had. Don't want to forget that, or it's gonna be less gold than we calculated. So I'm gonna take the lid off here. Those lovely fumes will escape, and we're gonna add in this little bit of gold here. You may need two hands for this, because, well, okay, I'm just gonna add these in. Don't have to really show it, because, come on, there we go, they're in there. Those will get dissolved through now too. Okay, you can see the reaction has died down. Now we get to add nitric acid very slowly and carefully. You can see, let's see if I can show you this. Most of the gold is already dissolved, like it's just little chunks left. So our calculations were good. Just gonna add a little bit of this, but it's gonna get crazy if you add too much. So let's see here. Ooh, that might be a little too much. It's actually not that bad of a reaction this time. Like I always say, this isn't stuff you want to breathe in, so make sure you're either in a fume hood or have a fan blowing it, or you're downwind, or sorry, upwind, so the wind is blowing away from you. Should add, not sure if I need any more hydrochloric acid. I think we're okay for that. I think it's a ratio of usually 4:1 hydrochloric to nitric. Don't quote me on that though, because I cannot remember if it's 4:1 or 3:1. But I may add just a little touch more in there, just so the gold has enough liquid to dissolve into. Just a touch. Now we got a little bit of free nitric acid and a little bit of free hydrochloric acid in there to finish off the rest of this gold. This is turning out really good. We're not getting a lot of waste here. And we're just going to let this boil up. I'll put the heat up a bit to 3. And it's just a waiting game now. But that's what you want to see. So our solution is done. We've dissolved almost everything. There's, as you can see, there's a couple little chunks in there, which I pretty much purposely left because I didn't want to pour more nitric acid in there than I really needed. So might be, half a gram left in there. I'm not even sure if that is gold. Well, it probably is, but it wasn't dissolving as quick. So there's a chance that it's not. But I'm going to recover that later. I'm going to keep that aside. And we can always use that in our next gold refining. So that may affect our numbers a little bit when we do the final weigh-in. You can see there's just a little bit crumbs. But that's okay. That just means that we've used up all of our excess nitric acid, and we won't have to worry about that part when we go to the next phase. But I'm gonna, like I said, I'm gonna put this through the filter, so we'll have a nice clean liquid, and any of this little bit of crumbs, or I assume it's gold crumbs, but not positive, I'm going to store it for my next gold refining. And I'll just throw that in with the aqua regia next time. So nothing goes to waste, but we have a nice clear solution otherwise. And we're gonna, let this cool down a little bit. It's still hot. I want to get it cool enough that, you know, you can touch it. Obviously not the liquid, but you can touch that and not feel the heat. And then I'm going to run it through just my regular filter, since it's mostly liquid and it shouldn't take long. And get it nice, clean, filtered. Put it in a nice, clean beaker. Then we add distilled water. You know, put half a liter of distilled water in it. And then we use our sodium metabisulfate. And that's going to precipitate the gold, and you will see that, how it happens. And it's pretty cool to watch, but it is probably the most satisfying part of it, but it's also the most nerve-wracking part, and definitely the smelliest part, because that stuff really stinks. But if you're going to have any issues with loss or contamination, or if anything can go wrong, the next few steps are the parts that can all happen. So you have to be very patient and particular. You don't want to rush the next few steps. You want to keep things as clean as possible, so you get a better end result. We got a nice clean liquid here, but like I said, we're going to start by filtering this through, so there'll be no solids at all in our liquid. So when we do precipitate the gold, it's going to be pure gold and nothing else. And that's the next step we're going to do right after this. Okay, we can touch this and not get burned, so it's it's nice and cooled down. Got our little filter here, it's all nice and clean. In a small beaker, we're just going to pour this into our filter. That yellow solution is all of our gold. And there's our little bits there, which I'm going to keep. What I'm going to do, what I'm going to do is get a little small beaker, or maybe even a glass holder, and just kind of squirt those out with my trusty little squirt bottle and save those, because they look like they could be gold, but I'm not sure because it didn't fully dissolve. But I'm going to save those for the next refining, but until then, it's going to filter this out and get a nice clean solution. Okay, so it's almost fully out. I got the little chunk of gold or whatever crumbly bits that was in my filter. Just letting it filter out. Kind of looks like mango juice, but that is all of our gold in there. So when this goes down, I'm just going to give the filter a little rinse with the spray bottle just to get any excess gold out of it. And I'm going to put these little chunks in a little gold, or in a little glass cylinder to hold on to for the next refining, just in case it is something we want to keep, which I'm sure it is. So we're going to refine that next time, but until then, this is what we want right here. Looking good. So we got a little bit of junk in the filter. I'm just doing a couple little squirts here just to wash out any remaining gold, because that yellow stuff is definitely stuff we want to keep. So I also have a little glass stick here, and sometimes things get clogged. You just have to scrape it off the little bits of the filter there so they can get through. Yeah, these are actually pretty hard chunks. I don't know if this is gold. Not sure what it could be. Some sort of metal that doesn't get dissolved with aqua regia. It's looking pretty clean. What I'll do once I get most of this yellow out, I'm going to take the filter out, and I've got this little mini flask right here. I'm going to fold the filter up and just store it in there. And then our extra fine, we can just take the entire filter out and throw it in. And it will all be dissolved. Assuming the stuff is gold, which I'm not sure. But and even little bits of yellow we can recover from storing it and doing it in our extra fine. So it's not like we're gonna lose gold, even though in the end our count may be down a gram or two, but it's not a complete loss because we do have this filter for the next refine. So it looks like we're getting most of it out. It's going through. Our mango juice is looking good. Just gonna do a couple more little squirts here. I'm using distilled water in my squirt bottle, which is fine because we're going to be adding distilled water to this anyways. So this is totally fine to do. I think that's going to be good for now. I'm going to take the filter out once the rest of this little liquid goes in, and I'll put it in that little beaker, and I'm going to transport what's in this beaker into my big beaker, and I'm going to fill it up with distilled water, probably just to about there, and then we're going to start to precipitate the gold out of it, and we'll get to that right after that. Okay, so I rinsed out, sorry about that, the wife came out. So I rinsed out this beaker, and I rinsed out my filter, put the little bit of filter in this small beaker, and put everything in my giant beaker here, and put some distilled water in it. And now, the part that really stinks, but it's also a pretty satisfying thing. This is sodium metabisulfate. And as soon as you put this into the liquid, the gold is going to start to precipitate right away, and it's going to look like brown, pretty much brown dust. So I'm just going to do a little bit at a time. So I'm going to get it up here. We're just going to do little bits at a time, and you're going to see the gold precipitate almost instantly. If it starts to fizz, it might mean there's a little bit of nitric in there. Just going to stir this in a bit, and there's the gold precipitating. You can see all that brown stuff is pure gold. It's starting to look like chocolate milk a bit. This stuff is nasty smelling, so definitely stay upwind so you don't have to smell this stuff, and do it outside. And just do little bits at a time. Stir it in as you go. And we're going to leave this overnight. Usually only needs a few hours, but it's getting later in the day, so I'll just leave this overnight, and all the brown gold dust will settle to the bottom, and then we'll filter it out, and we will have a nice pure gold dust. Pretty cool. All that brown is all the gold we're recovering. That is pure gold and nothing else. So I think we're not getting any more reaction here. I'm thinking that's all we need. So we're just gonna let this set for the night, and in the morning I'll show you what it looks like. You should see a nice brown sludge on the bottom and be more clear on the top as everything settles. And then we'll continue on from there. Okay, we are the next morning. You can see all the gold has settled to the bottom. I left it outside, so there's a little bit of ice in there as well. Just little icicles at the bottom, but it did not freeze. Probably because of the acids, but all that brown stuff is our gold. So what I'm going to do next is we're going to remove the liquid and we're going to dispose of it because it stinks and there's nothing more we can do with it. And then going to rinse it out a bit with water. Gold is heavier than water, so as you rinse off the gold with distilled water, the gold should remain in the beaker at the bottom. And then we're going to do two more things and then we're finished. First, after rinsing, we're going to do just a very tiny bit of nitric acid just to boil off anything that isn't gold that may have lingered around. There might be a little bit of excess sodium metabisulfate in there. Anything that's white could be that. The nitric acid boil will remove any of that stuff. Then we will rinse it again with distilled water, and then we'll do a quick little hydrochloric acid rinse or boil as well. So we'll do a nitric boil, rinse it, hydrochloric acid boil, rinse it, and then I think we'll do a little bit of hot distilled water, a couple of hot distilled water pours, and then we let it dry out, and that's going to be our pure gold powder. Like I said, this is the time that you want to be very picky with what you do. You want to be careful with it, but I prefer to do more than less. I don't know if you need to do these nitric and hydrochloric acid washes and boils, but I like to do it just so I know I'm getting the purest stuff I can get. I cover it just enough that the solids at the bottom will be covered in the nitric acid, so there's no calculation, there's not a lot of it. Literally like, I don't know, 10 to 50 milliliters of each acid, and that's it. I prefer to do more than less. I'm not sure if other refiners do it, but at least I know when I do that, I get the cleanest product I can get. Even if I use a little bit more acid than you may need. It's better safe than sorry. So that's our stuff right there. I'm going to filter this off, and then, by the way, this stuff really smells too. So I just brought it in the garage for a minute, but you can already kind of get a pungent smell out of it. So I'm going to open up the garage again and get it on my table and start with the boils. So since I had a little bit of ice in there, just because I left it overnight, just little icicles, I just put some distilled water in. I dumped off whatever I could of the other stuff. You can see some white in there. That's the excess sodium metabisulfate. But right now I'm just going to do a little boil with distilled water just to melt everything in and clean off the clean off all the sodium metabisulfate and aqua regia. But that's what it looks like. Looks pretty cool. I'm just going to give this a light boil to warm up. Then I will dump off all the liquid into my waste container. And then I will start with some light nitric acid boil, and then a light hydrochloric acid boil. But make sure if you do that, after your nitric acid, you want to rinse it good with distilled water, because once you add hydrochloric acid, and remember hydrochloric acid and nitric acid together will melt or will dissolve this, which is what we don't want. We want to do them separately, so we clean off anything in there that might not be pure gold. But that's pretty much it. That's what we're going to be doing this morning. But it looks pretty cool, eh? Nice and clear. Nice gold. It's a dark brown right now, but we're going to get it to a nice light brown. And the lighter brown you can get, it means the more pure it is. So this is our job for this morning, and then we will be complete with our gold. Okay, I heated this up. Don't want to boil it because I just really wanted to get it warm. This really doesn't do anything to purify it. This is just warming it up, getting any of the ice that I had maybe in there from overnight or whatever in there. Just warmed it up. I'm going to go dump this into my waste bucket, and then I'm going to start with the nitric acid. I will show you my waste bucket. I leave it outside because this stuff really smells. But look at that, it's nice and fluffy now. Kind of looks like sand. It's exactly what you want. And now we will turn this down. Actually, I'll turn it off. And I'll go dump this outside, and then we'll start. So I got a couple waste buckets out here. These are the ones that contain like sodium metabisulfate and anything that is going to smell. But as you can see, all I have to do, and the gold will always stay at the bottom if you do it slowly, just going to pour it off into the bucket. All the solid remains at the bottom. Just do it nice and slow. Remember, this is the last few steps that you just want to take your time, no rush. There's our sludge at the bottom. Looks pretty cool. It's dark right now, but when after we do a couple of these little treatments, and you will see how light it can get. It's going to get a nice light brown. So we're going to go start the nitric acid. I'm going to put just enough to cover a little layer over it. Don't go crazy on it, just enough to boil it in. And that's where we're going to start our purifying process. So I got my nitric acid ready. It's right here. I turn the heat up on our little gold dust here. And I'm literally just going to pour enough just to cover it. Which you'll see. Oh, that's plenty. Even that. It's probably more than I needed. Stir it around a bit. Turn the heat up just to a nice light boil. Doesn't even have to boil as long as it's pretty hot. And for this, you can see barely any, just enough. This part of it is something you don't really need to rush. You can let this boil as long as you want, really. The longer you let this boil, or even if it just sits off the heat, the better end result you're going to get. So I'm just going to let this go for, I don't know, until some of this nitric acid even dissolves or evaporates. Maybe an hour, just on a low heat. Maybe I'll put it to 2. Really no rush. Take your time with this stuff. It's just going to get out any excess impurities if there are any. This is the step that can mean 99% to even 999s and 49s. It's all about the purifying, so just take your time. Let that simmer for even an hour or 2, whatever you want. You can already see it's already turning a lighter brown. This is our nitric acid boil. So what I'm going to do, because I can still smell some of the sodium metabisulfate, which we expect, while this is boiling off with the nitric acid. So what I'm going to do is turn off the heat, let it cool down naturally so the nitric is back down to a cooler temperature. It's outside. And then I'm going to dump this little bit of nitric in the waste container. And now I'm going to do it again. Just another nitric acid boil on a low heat. And that'll be our second nitric boil. And depending on what it looks like and if I can smell any stuff we don't want in there, I'll do a third one if I have to. Like I said, this stuff, you just take your time, keep doing it over and over, and you're going to get a nice clean result. So I'm going to turn off the heat and let that cool down. And we've got a bunch of snow, so there's people out doing driveways, so it's going to get loud, so I'm going to shut this off for a few minutes and continue on. So I just dumped off the nitric. Put some distilled water in there. I'm just going to give it a couple of rinses. But look how light that color is already from what we just had. We're getting to a lighter brown. Just going to swish this around and clean off any acid or debris that we can at the moment, and then we're going to do the nitric again. See how the gold always stays at the bottom, so when you dump this, it's just the liquid. You can let that settle for a minute and then it'll all go to the bottom, so when you dump it, you don't even really need a filter. Just do it nice and slow. Look at that. All the gold will stay at the bottom. Okay, dumped off the distilled water, and we're just going to put some more nitric acid in here. Same amount, just a little bit, just enough to cover the top. Swish it around a bit. And we just let that boil for another 15-20 minutes. Can't stress it enough to do this outside. Either have a fan blowing on it, a fume hood, or at least make sure you're upwind, because you don't want to be breathing this stuff in, especially when you get to like the sulfuric stuff. It really smells. These can be toxic, so always do it outside and make sure you're not in any wind that can blow this stuff into your face. But look how clear that is. It's looking really good. May get a stir stick and just punch these little bits here, so just in case there's anything hiding in them, these little chunks. I think that's what I'm going to do next. Don't really want any chunks in there if you can help it. It might just help the solution here. Let me just... There we go. It's very crumbly, which is a good thing. Just give it a little stir. Let the nitric acid dissolve anything that you don't want in there. Remember, the gold will not dissolve from this, so don't be afraid of it. Give it a stir, give it a shake, break any of these little crumbs down so the nitric can do its job and just get anything we don't want. That's good there. Just gonna let that sit for a bit, and then we'll probably do one more rinse with distilled water, and we'll start hydrochloric acid after that. So just completed my second nitric boil. I dumped it into my waste container and rinsed it out with distilled water. Now we're going to do a light hydrochloric acid rinse. Same idea, just enough to cover it. Swish it around a little bit, get it all in there. And just do a nice light boil. Got to make sure all your nitric acid is out of there, so rinse it well with distilled water. And we'll just do this for 10 minutes, and then we'll do a nice distilled water boil, and then it's going to be complete. And we should have pure gold. Pretty cool. Okay, we've done all our boils, and that is our pure 3/9 fine gold powder. That's what it looks like. The only thing we have left to do, I'm just going to give us a little boil with distilled water, pour it off, and then we got to dry out the powder, which I usually just put on my hot plate and let the water slowly evaporate. But that is complete. And what I'm going to do is put this on the heat right now, give it a little bit of a boil, pour that off, and then we'll start evaporating the distilled water, and then that's it. That's our gold powder, and I'll show you that what it looks like when it's complete. Okay, so this is our end result. Other than just drying it out a little more, that is it. That is our pure 3/9 fine gold powder. Just got to dry it out some more, as you can see, and it'll lighten up even more. But it's a nice light brown color, if you can see it. Looks really good. It's perfect. We'll dry it up and we'll give it a little wave. But with this, all you have to do is melt it, and you'll have solid gold. That's all you got to do. Just melt it up, and you're good to go. Got still a couple little brown spots, dark, because it's still got some liquid in there. But as it dries up, it's going to lighten up. And that is the entire process of gold refining. For this, I think I'm just going to keep it in. I've got a little glass tube here. I throw it in. I got a little from before in there still. You can see the color. I'm just going to leave it in there, and then I melt it as I go. That way, I keep it pure and I don't contaminate with anything if I don't need to. But that is the gold refining process. Hope you guys enjoyed. I'm not going to melt this down right now. Just going to leave it as powder and melt it as you go.